Right, so just a difference between strong acids and weak acids. So I have a list of 6 strong acids that you should memorize. Hydrochloric acid, hydrobromic acid, hydroiodic. Bromine, chlorine, and iodine are all on the periodic table very close to each other, so it should be easy to remember. Then we've got perchloric acid, nitric acid, and sulfuric acid. Just a note, sulfuric acid has 2 protons. Proton is H+, but only the first proton that comes off is strongly acidic. So that'll make sense later. Weak acids are all the rest. So you'll notice in your halogens group, fluorine is not there. But HF is actually a weak acid. I have nitrous acid here as well, HNO2, but I wrote etc. because any other acid we would consider a weak acid. Difference is strong acids dissociate completely in water, and that makes them strong electrolytes. Electrolytes, if you have electrolytes in water, then that solution will conduct electricity. You dissolve ions in water, it'll conduct electricity. So HCl, you put it in water, you're going to get chloride, and you're going to get these protons coming off. We're going to get H+ coming off and attaching to water. So we get hydronium. So any of these, if you have a solution of these, it's going to conduct electricity very well. This is going to be important. Knowing the difference between a strong acid and a weak acid is going to be important when writing a net ionic equation. So let's take this for example. So this is HBr. HBr is a strong acid. So when you see it's aqueous, you split it apart and you write Then we've got sodium hydroxide. It's a sodium compound. They dissolve very well, so we split that apart into the ions. You got water. You're going to leave that together because it's a liquid. And sodium bromide is aqueous. We split it apart. Okay, so we have the complete ionic equation that I just wrote, and now I'm going to get rid of any spectator ions. We can see bromide appears on both sides. I'm going to get rid of that. And sodium as well. So there's your net ionic equation for a strong acid and a strong base. Sodium hydroxide is considered a strong base. So H+ plus OH gives us H2O. I have another example. This is HNO3 called nitric acid, another strong acid. So we see it as aqueous and we split this apart. We get nitrate ions and H+ ions. Sodium hydroxide, I'm dealing with the same strong base each time. Okay, so we have our complete ionic equation there. And again, we're going to get rid of any spectator ions. We see nitrate is a spectator ion. And again, sodium, the spectator ion. So you could do this with the other acids, other strong acids if you like. You're going to come up with the same thing each time. The net ionic equation for a strong acid plus a strong base is H+ plus OH- yields water. All right, so for strong acids, when you're looking at strong acids, you really want to treat that anion that the H+ is with, you want to treat that species as a spectator ion. Last one is HNO2. HNO2 is not a strong acid. This is a weak acid. It's nitrous acid. So that means we don't break it apart. It does not fully dissociate in water, so we leave it together. Still dealing with a strong base, sodium hydroxide. Okay, so we have our complete ionic equation. Now we're going to get rid of any spectator ions, and the only one I see is sodium. And we have the weak acid plus hydroxide yields water, and the conjugate base of the weak acid. We have this NO2 minus ion that's remaining. So notice the number of spectator ions would equal the number of strong bases or strong acids that you have. In this case, we had a strong acid and a strong base. So we had two strong species, and so we got rid of two spectator ions. Down here, and same thing here. Down here we had a weak acid and a strong base. So yeah, we had one species that was strong, and we only had one spectator ion.